Alright, in number 5, things change a little bit. First few that we've done all had the same basic form to them. We had something raised to a power in terms of x. Number 5, that's not the case. Here we could do the derivative of this using product rule if we wanted to, but we can actually use logarithmic differentiation as an alternative. So let's take a look at how we can do that with a problem like number 5. Same steps to start with. We're going to take the natural log of both sides. Actually, let's rewrite this. Let's not use a square root. Think of it as 4x plus 7 to the 1/2 times x minus 5 cubed. Remember, we're taking the natural log of this whole thing. Now, before we just had exponents and we brought them out in front. Now we're going to rewrite this using some more of those properties we talked about at the beginning of notes. So for this, we can do a few things. We can split this up. Remember, if we multiply two things, we can split those up using addition. So we'd have natural log of 4x plus 7 to the 1/2 plus natural log of this to the third, but instead of having that exponent, remember, we can bring that out in front. So for this first one, we'd have the 1/2 can be brought out in front. The second one, we have natural log of x minus 5 cubed, but we can bring that 3 out in front. So now we've rewritten this so that we don't have any of those exponents anymore. We split up the multiplication, and now we can go ahead and take the derivative of both sides. So left side, 1 over y times dy dx. Over here, now we have addition in between here, so no product rule. It's 1/2 natural log of 4x plus 7. So the 1/2 is a constant, stays out in front. Derivative of natural log of 4x plus 7, we get 1 over 4x plus 7. But then we have to multiply by the derivative of 4x plus 7, just using the chain rule. Our other one here, 3 stays out in front, times 1 over x minus 5. Derivative of the inside for this one is just 1. So you don't really need to write it, but just to remind you, there it is. So we can do a little simplifying on the right side. The 2 and the 4 simplifies. So we get 1 over y dy dx equals 2 over 4x plus 7 plus 3 over x minus 5. And then our last step, just multiply both sides by y. So dy dx equals 2 over 4x plus 7 plus 3 over x minus 5, all times y. Alright, let's take a look at another one, number 6, where it's not the same setup as before, but we can use logarithmic differentiation to change it up a bit. If we didn't use logarithmic differentiation here, we'd have to deal with the product rule and the quotient rule, or we rewrote this with a negative exponent, we'd kind of do an expanded product rule with 3 products. But we can break it down using logarithmic differentiation. Take the natural log of both sides. So we have natural log of this whole thing over here. I'm going to rewrite this as x squared plus 1 to the 1/2 all over x plus 1 to the 2/3. So our next step is to break this up, this right side. So we have natural log of y, that's going to stay. Over here, we have multiplication, exponents, and division. So to split up the multiplication, we're going to have natural log of x plus natural log of x squared plus 1 to the 1/2, but I'm going to go ahead and put that 1/2 out in front. Then, since we're dividing this, we're going to subtract natural log of x plus 1 to the 2/3, but we can put that 2/3 out in front. So multiplication calls for addition, division calls for subtraction, and we bring those exponents out in front. So it's just a matter of expanding that, which you guys had practice in pre-calc. Alright, once we expand it, get it split up, now we can take the derivative of both sides. So once again, we get 1 over y times dy dx. And then we're taking the derivative of each part. So derivative of natural log of x 1 over x. Here we have a constant out in front, times 1 over x squared plus 1, times derivative of x squared plus 1 is 2x. Minus 2/3 times derivative of this, we get 1 over x plus 1, times derivative of x plus 1 is just 1. So just want to try and clean up a little bit over here on the right. 2's cancel out, and that's about it. So we're going to get dy dx equals this whole thing times y. So 1 over x plus x over x squared plus 1 minus 2 over 3 times x plus 1. And that whole thing is multiplied by y.